Since we cannot be in lab due to COVID-19, we are using an automation simulation program called FactoryIO. First off, we are going to go over the plan that I had set out for my second semester project. My plan goes as follows. We will have two machining centers, one building bases here and one building lids here. They will converge right here and go to an assembler where the robot will place the lid on top of the base, which will be our completed part. After the part is complete, we will go up this conveyor, and this was needed in order to put the part into a box that had to be high enough. And after we put the part in the box, this conveyor will start, and then the stacker will load this warehouse from the bottom right going to the left and up. So this will be our first box, and this will be our last. There will be two stopping methods, one which will be a stop push button which can be controlled from either the HMI or the factory control panel. The other stop being an e-stop, which will completely shut down FactoryIO and will have to be restarted. The stop button will also allow all machines to come to a proper stopping point. This means that some machines may continue moving once the stop button has been pressed. The stop button will immediately stop the machining centers. If the part makes it past the machining center, it will go through the conveyors until it reaches the assembler. The assembler will immediately halt on the step it's on. However, if suction is on, it will remain on to keep the part on the end. If the part makes it past the assembler, it will go until it is put into the box. If the box is in the middle of the conveyor and the stop button is pressed, the conveyor will immediately stop. However, if the box makes it to the stacker will follow its process until it has completed putting the part away and returning to its home position. The HMI will have an overview of the entire plant and will show which machines are on. Each machine will be able to be clicked upon, and a pop-up with detailed information will show. Both machining centers have the same information, such as a machining door open, the machine busy, machine error, machine progress, and that's the progress it is in the when the door is shut, the total cycle basis produced, and the total lifetime basis produced. The assembler will show which steps are on, whether or not a lid is grabbed, the bases and lid stop blade, the cycle parts produced, and the lifetime parts produced, the horizontal set points and position, and the vertical set point and position. The stacker will show which positions have been filled, the step that it is on or completed, the stacker, whether the stacker is turned on and ready, and which position is going to be filled next. On top of that, there is going to be an alarm screen, which will show all of my active alarms, not anybody else's. Next, we will be going over the programming methods that I use for each machine. First, the I/O map. This allows us to take a tag that we know and understand and convert it to a Boolean, integer, or real tag in FactoryIO. So here is a Boolean input, which will take a Boolean input and will convert it to a tag that we know and understand. The I/O map is split up by machine. So the machining center inputs are here, the assembler machine inputs are here, and the stacker machine inputs are here. And then we go to the controller tags, which are the start and stop logic. Then we have the integer input tags and the real input tags. And then we go to the discrete outputs. So here's the machining outputs, which take the tag that we know and understand and convert it to the Boolean output, which controls the machine on FactoryIO. Then we have the assembler machine tags, the stacker machine tags, and the stack lights, which are at the very bottom. The real outputs, the integer outputs, and each machine has a spare, two spares at the end, in case more functionality needs to be added later. The machining center was the easiest machine to program. However, I did have issues because the bases machine will always produce bases faster than the lids machine. This is because the base has less cuts to make, and therefore it produces faster. In order to solve this issue, I made logic that will stop the base machine until the lids machine has completed its part, and they will both start back up at the same position. The assembler was programmed in steps. I did this to show which machines have been completed and which step the machine is currently on. The stacker was the most challenging machine to program in my project, and this was because I had to learn how to keep track of positions filled with an array. I am doing this by moving a 1 into an array based on the stacker position as shown here. This machine was also programmed in steps for the same reason as the assembler. Next up, I'm going to start the factory and put it in a time lapse for you guys to see. Next up, I'm going to turn on FactoryIO and I'm going to show you the HMI while running in progress. So I just turn on FactoryIO and you can see that both of the feed conveyors turn on and show green, meaning that they are on. And then as soon as the machining turns on, they are highlighted in green as well. So we're going to click on one of these and we will watch the machine progress go up after the door shuts. So now the door is shut and our machine progress goes up, and as you can see, the basis machine got done way faster than the lids machine. So you will see the basis machine, you'll see these conveyors turn on first, and then this one will stop. And then the lids machine turns on. The assembler pop-up is going to show that both stop blades are on because those turn on as soon as that part goes through here. And then as the steps are completed, those turn on and you go up one cycle part as soon as the part has gone through the sensor. So now we have fed the part into a box and it is now going down the conveyor to the stacker. And you can see that step 1 is on, and now step 2, 3, 4, 5, and the position is filled, and then the 6 is the return to home. And then it resets all the steps. And then you can see that the next position to fill is position 2, which is right here. You can also see that the horizontal set point changes as the steps go through, and the actual position changes as the steps go through, and the same thing for the vertical set point and position. Here we have now filled 2 spots, and the next position to fill is 3. And now we're going through the steps, and as soon as it reaches step 5, this position will be filled. Position filled, and then we reset. Now, if I were to toggle a basis or lids error, the entire machining process would stop. And you can now see that we have an active fault, and that it is a machining fault.